Hello everyone. In today's video, you will learn how to construct and test 4-bit PIPO parallel input, parallel output register.
At the end of this video, you will be able to construct and test 4-bit PIPO register using IC74LS95. Let us collect all the tools, equipment and materials required to do this practical. Digital trainer kit with user manual, IC74LS95 with data sheet, male-to-male jumper wires, magnifying lens. Let us discuss on PIPO, parallel input and parallel output in shift registers. PIPO stands for parallel in, parallel out, and it refers to a type of shift register in digital electronics. In a PIPO shift register, data is entered in parallel, all bits at once, and the entire set of data is available in parallel at the outputs. Parallel in, all the data bits are entered simultaneously into the shift register, typically on the rising or falling edge of the clock signal. Parallel out, after the data has been loaded, the entire set of data available simultaneously at the outputs. Each output corresponds to one bit of the parallel data. Parallel input data 1, 0, 1, 1 is presented at D0, D1, D2 and D3. The clock triggers the parallel loading of data into the flip-flops. After the clock pulse, the data 1, 0, 1, 1 is stored in the flip-flops. Parallel out, Q0 is equal to 1, Q1 is equal to 0, Q2 is equal to 1, Q3 is equal to 1. PIPO shift registers are used when there is a need to load a set of data in parallel and have it available at the outputs without any shifting operation. Let us discuss about the IC74LS95, which is available as a 14-pin dual inline package. The IC74LS95 is a 4-bit parallel access shift register with parallel load capability. Pins 7 and 14 of IC74LS95 are allotted to ground negative and +5 volt supply respectively. Pins 2, 3, 4 and 5, A, B, C and D are 4-bit parallel inputs. Pins 13, 12, 11 and 10, QA, QB, QC and QD are 4-bit parallel outputs. Pin 6 is the mode selector with mode control input at logic 1. Parallel inputs A is equal to B is equal to C is equal to D is equal to 0. Result in QA, QB, QC and QD equal to 0, 0, 0, 0. Pins 8 and 9 are for left and right shifts respectively. Construction and testing of a 4-bit parallel in, parallel out shift register using IC74LS95 PIPO. Collect all the components, check them and assemble the circuit of a 4-bit shift register on a breadboard using IC74LS95. Identify the IC74LS95 printed on the top of IC using a magnifying lens. Make sure that the IC is correctly aligned and that pin 1 is in the right position. Gently insert the IC into the breadboard in the digital trainer kit. Connect the pin number 7 to ground negative G and D and pin number 14 to +5 volt supply VCC. Connect the pin 9 to the clock input in the digital trainer kit. Identify the output LEDs as QA, QB, QC and QD in the digital trainer kit. Connect the pin 13 to output LED QA. Connect the pin 12 to output LED QP. Connect the pin 11 to output LED QC. Connect the pin 10 to output LED QD in the trainer kit. Connect the pins 2, 3, 4 and 5 to the toggle input switches in the trainer kit as A, B, C and D respectively. Connect pin 6 mode selector to input toggle switch. Switch on +5 volt DC power supply to IC74LS95. Apply logic 1 to mode control input through toggle switch. Apply a clock pulse to the clock input pin and apply 4-bit data input to parallel input pins as shown in the circuit diagram. Apply different parallel inputs and record corresponding output logic levels in the table. Input 0001 clock pulse 1, output 0001. Input 0010 clock pulse 2, output 0010. Input 0011 clock pulse 3, output 0011. Input 0100 clock pulse 4, output 0100. Input 0101 clock pulse 5, output 0101. Input 0110 clock pulse 6, output 0110. Input 0111 clock pulse 7, output 0111. Input 1000 clock pulse 8, output 1000. Input 1001 clock pulse 9, output 1001. Input 1010 clock pulse 10, output 1010. Input 1011 clock pulse 11, output 1011. Input 1100 clock pulse 12, output 1100. Input 1101 clock pulse 13, output 1101. Input 1110 clock pulse 14, output 1110. Input 1111 clock pulse 15, output 1111. Thus, we have constructed the 4-bit PIPO register using IC74LS95, applied different input, observed corresponding outputs and verified with the truth table. Hope now you will be able to construct and test 4-bit PIPO register using IC74LS95.
This concludes the session on how to construct and test 4-bit PIPO parallel input, parallel output register. Thank you.